Linux and Fundamentals Part 3. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is an Ansible playbook? Here's a strong way to approach it. A playbook is a YAML file describing an ordered list of plays and tasks, each naming an Ansible module and its parameters, that define the desired state to apply to a group of hosts from the inventory. Nice. Let's continue. Question 2. What is a role in Ansible? Here's a strong way to approach it. A role is a standardized directory structure that packages related tasks, variables, templates, handlers, and files for one piece of functionality, like install nginx, so it can be reused across multiple playbooks instead of duplicating the same tasks. Great. Moving on. Question 3. What is a task in Ansible? Here's a strong way to approach it. A task is the smallest unit of work in a playbook, a single call to an Ansible module with specific parameters, like installing a package or copying a file, executed in order against the targeted hosts. Alright, next question. Question 4. What is an ad hoc command in Ansible? Here's a strong way to approach it. An ad hoc command is a one-off Ansible module call run directly from the command line, e.g. Ansible all mping or Ansible web servers mservice a name equals nginx state equals restarted, for quick, single-purpose actions that don't need a full playbook. Let's keep going. Question 5. What is the Ansible template module? Here's a strong way to approach it. The template module copies a Jinja2 template file to a remote host, rendering any variables and expressions in it first, so you can generate host-specific config files, like nginxconf, from a single templated source instead of maintaining a separate static file per host. On to the next one. Question 6. What is idempotency? Here's a strong way to approach it. Idempotency means repeating an operation has the same effect as performing it once. It is essential for safe retries, payment APIs, event processing, and deployment automation. Detailed interview explanation. Idempotency should be explained as a system design concept with clear trade-offs. Start by clarifying requirements, users, scale, latency, availability, consistency, data volume, security, compliance, and cost. Then explain components, data flow, failure modes, scaling strategy, and operations. Production example. A scalable system often includes clients, an API gateway or load balancer, stateless services, caches, queues or streams, databases, object storage, workers, observability, CI or CD, and security controls. For Kubernetes or MLOps platforms, add GitOps, policy enforcement, model registry, feature pipelines, autoscaling, and tenant isolation. Best practices to mention. Scale stateless services horizontally behind load balancers. Use caching, queues, partitioning, and replication for performance and resilience. Define consistency needs before choosing database and replication patterns. Reduce blast radius with isolation, rate limits, circuit breakers, and progressive rollout. Include observability, slows, disaster recovery, and cost governance. Common interview follow-ups. Expect questions about CAP theorem, cache invalidation, database sharding, queue back pressure, multi-region failover, idempotency, API versioning, rate limiting, and how you would operate the system after launch. Good. Here's another one. Question 7. How would you optimize a Google Cloud Run service that is taking a long time to start? Cold starts. Here's a strong way to approach it. Set a minimum instance count so warm instances are always ready instead of scaling to 0. Reduce container image size and simplify startup. Lazy load heavy dependencies. Avoid unnecessary initialization work at boot. Enable CPU always allocated if the workload needs background processing. Tune concurrency so fewer cold instances are needed under load. And use a smaller or leaner base image, distroless or slim, so the container starts faster. If cold starts are still an issue for latency-sensitive paths, keep min instances above 0 permanently for that service. Nice. Let's continue. Question 8. What is a load balancer? Here's a strong way to approach it. A load balancer distributes incoming network traffic across multiple backend servers or instances, improving availability and throughput and removing any single instance as a point of failure. Great. Moving on. Question 9. What is DNS? Here's a strong way to approach it. DNS translates human-readable domain names into IP addresses and other records. It is critical for service discovery, internet routing, email delivery, and application availability. Detailed interview explanation. DNS should be explained from a production troubleshooting and security perspective. These questions test whether you understand operating system fundamentals, networking behavior, access control, and how to debug safely under pressure. Production example. If a service is slow or down, you may check service state with systemtl, logs with journaltl, processes with top or top, memory with free and mstat, disk with df and iostat, sockets with ss, DNS with dig, connectivity with curl or nc, and packets with dump. For security topics, connect the answer to least privilege, hardening, encryption, segmentation, patching, and audit logs. Best practices to mention. Start with impact, recent changes, logs, metrics, and resource saturation. Validate DNS, routes, firewall rules, TLS certificates, and dependency health for network issues. Use least privilege, patching, MFA, secrets management, and logging for security. Automate repetitive operational tasks with scripts and runbooks. Avoid risky production commands unless you understand blast radius and rollback. Common interview follow-ups. Interviewers may ask how to debug high CPU, memory leaks, disk full, inode exhaustion, DNS failures, packet loss, TLS issues, SSH access problems, or suspicious activity. Strong answers are step-by-step and evidence-driven. Alright, next question. Question 10. What is a firewall? Here's a strong way to approach it. A firewall is a network security control that inspects and filters incoming and outgoing traffic based on rules, source or destination IP, port, protocol, blocking traffic that doesn't match an allowed rule. Let's keep going. Question 11. What is a subnet? Here's a strong way to approach it. A subnet is a smaller, segmented range of IP addresses carved out of a VPC's larger address space, typically used to separate resources by tier, public-facing versus private or by availability zone. On to the next one. Question 12. In simple terms, how does network traffic flow from a client to a pod in GKE, client to load balancer to service to pod? Here's a strong way to approach it. A client request hits an external load balancer, provisioned via a Kubernetes ingress or service of type load balancer, which forwards it to a node in the cluster. Kuba proxies routing rules on that node, or the LB directly, with container native load balancing. Send the request to a pod matching the service's label selector, using the service's stable virtual IP as the indirection layer so the client never needs to know individual pod IPs, which change as pods are created and destroyed. Good. Here's another one. Question 13. What is VPC peering, and how does it differ from Cloud Interconnect and Partner Interconnect? Here's a strong way to approach it. VPC peering connects two VPC networks, in the same or different projects or organizations directly over Google's internal network using private IPs, with no gateway or extra latency, but it doesn't transitively route through a third-peered network. Cloud Interconnect and Partner Interconnect instead connect your on-premises network to Google Cloud. Dedicated Interconnect is a direct physical connection into a Google colocation facility, while Partner Interconnect goes through a supported service provider for locations without direct physical access, both used for hybrid cloud connectivity rather than VPC to VPC peering. Nice. Let's continue. Question 14. What is IAM? Here's a strong way to approach it. IAM, Identity and Access Management, is the system that controls who, users, service accounts, applications can do what, which actions, on which resources, typically through roles and policies that follow least privilege principles. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.